Something is heading our way. This is not science fiction. This is not conspiracy theory. This is real, detected by multiple observatories around the world, and in exactly 52 days, on December 19th, 2025, it will be at the closest point to Earth it will ever reach. Its name is 3I Atlas, the third confirmed interstellar object traversing our solar system, traveling at an incredible 130,000 miles per hour, the highest velocity ever recorded for an interstellar visitor. And while space authorities assure us we are safe, that the distance of 170 million miles is sufficiently large to pose no threat, one question persists in the shadows. Are we really being told everything? Before we dive into this mystery that is literally approaching us, subscribe and hit the bell, because what comes next, you won't want to miss. It was on July 1st, 2025, that the Atlas telescope in Chile first detected this cosmic intruder. Initially cataloged as A11PL3Z, it quickly became clear that this was no ordinary asteroid or periodic comet from our solar system. Its orbit was hyperbolic, with an eccentricity of approximately 6.1, a number that means one thing: it is not gravitationally bound to our sun. It came from outside, from the vastness of interstellar space, possibly from the thick galactic disk, a region formed about 9 to 13 billion years ago, during the period called Cosmic Noon, when star formation in the Milky Way was at its peak. Pre-discovery observations revealed that it had been photographed since June 14th, but no one had noticed. When finally identified, multiple telescopes, including Hubble, James Webb, and ground-based observatories like the VLT, quickly pointed their instruments at this rare visitor. But what happened next left scientists in shock. The first spectroscopic analyses revealed something completely unexpected. 3I Atlas possesses a bizarre chemical composition, extremely rich in carbon dioxide and carbonyl sulfide, but surprisingly poor in water, the opposite of what would be expected from an interstellar comet. Even stranger, the object exhibited CO2 and CO emissions at levels inconsistent with expected thermal sublimation, especially considering that surface temperatures remained near absolute zero. The Hubble Space Telescope recorded subtle accelerations and weak jets that could not be explained by the gravity of nearby planets alone. And then came the discovery that made many raise their eyebrows. Observations by the VLT detected atomic nickel and cyanide emissions at concentrations similar to those seen in solar system comets, but with a release pattern suggesting low-energy activation mechanisms, such as photodissorption or mild thermolysis of organometallic compounds. It's as if the comet was awakening in a way that doesn't quite fit traditional models. And this is where things get really strange. During September 2025, Hubble images revealed something disconcerting. 3I Atlas displayed an antitail pointing toward the sun, a rare but known phenomenon, with a projected elongation ratio of 2:1. Studies suggested that this structure was dominated by H2O ice grains ejected from the nucleus by CO2 sublimation. But then, unexpectedly, the antitail transformed into a conventional tail pointing away from the sun within a matter of weeks. This metamorphosis was attributed to the exponential increase in sublimation rate as the comet approached the sun, and to the decreasing residence time of ice grains in the observation field. Meanwhile, trajectory changes were recorded, subtle but measurable changes that seemed inconsistent with Mars's gravity and solar radiation pressure alone. Some speculated about asymmetric outgassing forces, while others raised bolder hypotheses. Could there be some kind of more complex non-gravitational activity at play? Do you believe this could be coincidence? Comment below what you think. the trajectory of 3I Atlas is, in itself, intriguing. With an inclination of 175 degrees, essentially retrograde, only 5 degrees off the ecliptic plane, the comet passed dangerously close to Mars on October 3, 2025, at just 17 million miles. This allowed Martian orbiters like MAVEN, Mars Odyssey, and others to conduct valuable observations during the period when the comet was hidden from Earth by solar conjunction. At the end of October, it reached its perihelion, the closest point to the Sun, at about 126 million miles, moving at 42 miles per second relative to the Sun. This almost perfect alignment with the ecliptic raised eyebrows in academic circles. A semi-pedagogical academic paper, though speculative, suggested that such a trajectory would offer several benefits to an extraterrestrial intelligence, as it would allow access to our planet with relative impunity, and that Earth's solar eclipse at perihelion would permit a clandestine reverse solar Oberth maneuver, a high-efficiency strategy for an interstellar spacecraft to break and become gravitationally bound to the Sun. While this hypothesis is highly controversial and does not represent mainstream scientific view, it illustrates how statistically uncommon 3I Atlas's trajectory is. The probability of passing so close to Venus, Mars, and Jupiter is only 0.005%. And what if I told you this story isn't over yet? But let's return to the central question. Is this distance of 170 million miles on December 19 really safe? From a physical and gravitational standpoint, the answer is unequivocal. Yes, this distance equals 1.8 astronomical units, almost double the distance between Earth and the Sun. At this distance, the gravitational effect of 3I Atlas on Earth would be infinitesimally small, orders of magnitude weaker than the Moon's influence, which by itself does not cause earthquakes. Viral theories on social media that connected the comet's passage to global earthquakes were categorically debunked by geologists and astronomers. Earthquakes are caused by tectonic plate movement, not by external cosmic influences. For an interstellar object to directly affect Earth's crust, it would need to exert a measurable gravitational or magnetic attraction, something 3I Atlas simply cannot do at such a distance. NASA, ESA, and space agencies around the world reiterated that the comet poses no threat to Earth or any planet. And yet, fear persists in pockets of the internet, fueled by misinformation and misinterpretations of scientific data. But what about hypothetical scenarios? Could 3I Atlas's trajectory change in the next 7 weeks unexpectedly? Theoretically, trajectory changes in comets can occur due to asymmetric outgassing. Jets of gas and dust released irregularly from the nucleus surface can act like small thrusters, slightly altering the orbit. This phenomenon has been observed in solar system comets and was even intensely debated in the case of Oumuamua, the first discovered interstellar object. In the case of 3I subtle non-gravitational accelerations have already been detected by Hubble, but all consistent with natural jet forces. For there to be a significant trajectory change, enough to transform a safe passage into a threat, a catastrophic event would be necessary. Massive nucleus fragmentation, a violent explosion of volatiles, or some kind of unobserved external perturbation. None of these scenarios has been evidenced in continuous observations. The comet has, in fact, demonstrated impressive resilience. It survived a powerful solar eruption without fragmenting, something that frequently destroys comets. Moreover, its orbit was calculated with extreme precision using data from multiple telescopes and extended pre-discovery observations, resulting in minimal margin of error. The maximum approach to Jupiter in March 2026, for example, is calculated at 33.28, plus or minus 0.28 million miles. These orbital calculations are robust and continually refined. So, are we being completely informed about potential risks? The most honest answer is probably yes, but with caveats. All major space agencies, NASA, ESA, and others, have near-Earth object monitoring systems and established planetary defense protocols, including the International Asteroid Warning Network. In the case of 3I Atlas, transparency has been remarkable. Observations were shared publicly, scientific papers were published quickly in open repositories like arXiv, and official communications emphasized both safety and the object's scientific importance. However, there is always a layer of uncertainty in planetary science. Physical models depend on assumptions about composition, internal structure, and nucleus behavior, properties we can never measure with absolute certainty from a distance. The nucleus diameter of 3I Atlas, for example, is estimated between 1,440 feet and 3.5 miles, with the most likely value being less than 0.6 miles. But this is an inference, not a direct measurement. What they discovered next changes everything. JWST observations showed that the comet is unusually rich in CO2 and contains small amounts of water ice, water vapor, carbon monoxide, and carbonyl sulfide, a chemical signature that defies expectations. This exotic composition could result in unpredictable behaviors as the comet is heated. The reality is that 3I Atlas represents a rare and precious scientific opportunity, not an imminent threat. It is only the third confirmed interstellar object to visit our solar system, after Oumuamua in 2017 and 2I Borisov in 2019. Unlike Oumuamua, whose nature remains debated, 3I Atlas is unequivocally an active comet with coma, tail, and observed outgassing. It offers scientists a rare window to study the composition of material formed in another stellar system billions of years ago, during the galaxy's infancy. Multiple NASA and ESA spacecraft, including Psyche, Martian orbiters, JUICE, Europa Clipper, and even Hera, were positioned or redirected to collect data during the comet's passage, with some traversing its ion tail. These missions can detect capture ions from the comet and changes in the solar wind associated with tail crossing. Proposals were made for the Juno spacecraft orbiting Jupiter to perform maneuvers to intercept 3I Atlas's trajectory in March 2026, coming to within just 17 million miles of the comet, a proximity that would allow investigation of its nature far better than ground-based telescopes. Hit the like button if you love this kind of mystery. As December 19th approaches, the scientific world waits anxiously. 3I Atlas will be 1.8 AU away, more than 167 million miles of safety between it and us. On this date, the comet will again be visible to ground-based telescopes after its solar conjunction, allowing renewed observations of its activity, composition, and evolution. It will be a chance to witness how an interstellar comet responds to. The truth is that the universe always keeps secrets, and even with all our telescopes, spacecraft, and computational models, there is always a margin for the unexpected. If it were an intelligent signal, how would you react? What makes 3I Atlas truly fascinating is not the unfounded fear that it might pose a threat, but rather the genuine mystery it carries. Where exactly did it come from? What kind of stellar system formed it? Why is its chemical composition so different from typical comets? What does its presence teach us about the abundance of interstellar objects in the galaxy? These are the questions we should be asking. In a century where we have the technological capability to detect, track, and study visitors from other stellar systems. We should celebrate, not fear, these opportunities. 3I Atlas has traveled for billions of years through the cosmic void, a silent witness to galactic evolution, carrying in its frozen nucleus clues about planetary formation in times and places we will never visit. And for a brief moment, in December 2025, it will pass close enough for us to study it, admire it, and learn from it. As for the transparency of authorities, the evidence suggests we are being adequately informed. The risks are minimal, negligible, in fact, and widely communicated. Scientific observations are published in real time. Orbital data is continuously updated and publicly available through platforms like NASA Eyes on the Solar System. If there were a real threat, planetary defense protocols would be activated, and the international scientific community, which operates under public scrutiny and peer review, would certainly raise alarms. The real risk of 3I Atlas is not physical, but epistemological. It challenges our assumptions, confounds our models, and reminds us how little we still know about the universe beyond our small corner of the solar system. And perhaps, just perhaps, that is the most valuable lesson it has to offer. So, in 52 days, when 3I Atlas makes its maximum approach to Earth, don't look at the sky with fear. Look with curiosity, with reverence, with the understanding that you are witnessing something extraordinary, a messenger from another world, from another time, briefly crossing our orbit before returning to the interstellar darkness from which it came. It does not represent destruction. It represents discovery. And that, ultimately, is what makes us human. Not our capacity to fear the unknown, but our courage to study it, understand it, and learn from it. This mystery has held you until here. Hit the like button and subscribe so you don't miss the next chapter of this journey. The universe is full of unanswered questions, and here we go after all of them.